Alright, on the previous video we looked at introduction to differentiation, not necessarily using it in defined by limits, but in terms of calculus now. There's a lot of shortcuts, and there's also a lot of different functions that you have to know how to find the derivative of. So the next one is, what if you're taking two functions, like in this case, u and v, or we've used a lot as f of x and g of x. So what if you're taking the function f of x and multiplying it by the function g of x? How do you find the derivative of those? So that's called the product rule. So it's called the product rule because you use it to find the derivative of two functions that are being multiplied together. Pretty straightforward. Now there's a mnemonic to try to remember how to do this. It's pretty straightforward, but basically if you look down here, let's look down here first, then we'll go up to this yellow box. But if you're taking the derivative of some function u and some function v, the derivative of that is equal to u, that's your first function, times the derivative of v, your second function, plus your second function times the derivative of your first. Alright? So I have up here in this yellow box just a quick little way to remember that. Instead of u and v, I used s and p. And like if I have y is equal to x, I can write that as y prime. That means the derivative of y is equal to 1. So I use that notation up here in this yellow box when I say the derivative of s times p, for example, is s prime times p. So that means the derivative of s times p plus p prime times s. Alright, so if you look at this, that prime, imagine that prime being a little I, and what does that spell? Right, sip plus piss. So the product rule for high schoolers only, is the derivative of two functions is sip and piss. So it's s prime p plus p prime s. Pretty simple. We're going to do an example of that in a little bit, but before we do, let's go ahead and go over the quotient rule. So if the product rule is finding the derivative of two functions multiplied together, then the quotient rule is finding the derivative of two functions being divided. So here you have, again, u and v. So the derivative of u divided by v is, in your numerator, it goes v times du dx, so it's your lower function times the derivative of your upper minus your upper function times the derivative of your lower. Then in your denominator you divide that whole thing by the lower function squared. Alright, so this is called the quotient rule, and there's a little thing up here to help you remember it. So instead of using u and v, I use high and low. Alright, so high being your upper function in the numerator, low being your lower function in the denominator. Pretty straightforward. Alright, so it goes low d high minus high d low, and the d high just means the derivative of the high. The d low just means the derivative of the low. And it's important, you cannot mix those because subtraction is not commutative. It's low, you start on the bottom, d high minus high d low, over low low. So low d high minus high d low over low low, that is the quotient rule. And when we go through and do some of these examples, you'll see that's the way that I use it, by using the quotient rule, because it's just a little easier, since actually it's a song. You could sing it if you wanted to with a really high voice. Kind of funny. But if we look at some of these examples, for example, let's take a look at this one. Here, let's determine if we're going to use the product rule or the quotient rule for this one. Well, we have to use the quotient rule because you have, in your numerator, f of x, and your denominator, g of x. Alright, so we're going to designate our low function and high functions. So we have our high function as x squared plus 5x minus 1, and your low function as just x squared. Now we're going to go ahead and find the derivative. So d high is going to be 2x plus 5, and then d low is just 2x. Okay, now we can go put that low d high minus high d low over low low stuff to work. So the derivative, dy over dx, is going to be low, d high. Use parentheses for everything. Okay, use parentheses over every low, every high, every d low, every d high. So it's much less confusing when you go to simplify. So low, d high, minus high, d low, all over low, low. So x squared quantity squared. That's all the calculus involved. That's the easy part. As you'll find out in this class, calculus is the easy part. It's the algebra that's not. Because from here, okay, we did the calculus part, the low d high minus high d low over low low, because from here all we have to do is simplify, put together like terms. And that's where it gets tricky. So go ahead and try this on your own, and then come back here and check your answers, see how you did. So multiply these in, distribute them in, put together like terms, and do not forget this minus. That means you're subtracting every single term over here. Okay? If you multiply this in, then you have to subtract everything. So try this on your end, or on your own, then come back and see how you did. Okay, so here we are at the end product. Go ahead and check. If we go through this work, you multiply everything in. 2x to the third plus 5x squared minus 2x to the third minus 10x squared plus 2x here, not minus, plus 2x. Put together like terms. Those two are like, they cancel. These two are like, you get negative 5x squared, and there's no x to the first. So we have this, and you notice everything has an x in it, so then we can go ahead and get rid of an x out of everything, and we have just negative 5x plus 2 over 4x, and then that is our derivative. All right, so that's using the quotient rule. And right underneath we have another example. But on this one, you notice we don't know. We can do this using the chain rule, but we don't know what the chain rule is yet, so we have to use the quotient rule. But as it's written, it looks like they're multiplied, and they are. But since this is to the negative first power, we can go ahead and bring it to the denominator. And so everything has down here, so you have 1 minus x all over 1 plus x squared. So now you're dividing them. So now you have a low and a high, so we'll go ahead and designate those, and you'll try them on your own. So your low would be the 1 plus x squared, then your d low would be the 2x, and then your high is the 1 minus x, and then your d high is the negative 1. So go ahead and try this one on your own. Okay, again, it's very important that you try these things on your own and just don't copy whatever I put down. But try them on your own, then come back and see how you did. Okay, so if we take a look at this low d high minus high d low over low low, you would have dy dx is equal to, so here's your low, so that's just going to be the 2x, or sorry, the 1 plus x squared. And again, put everything in parentheses, every single part, like the low, the high, and all that in parentheses. So low d high minus high d low all over low low. So that's the quantity of 1 plus x squared squared. And again, folks, that's the calculus. The rest of it is just algebra. Calculus is the easy part here. All right, so if you don't have strong algebra skills, you're going to really struggle. So why don't you go ahead and finish this one on your own, then come back to the video to see how you did. Okay, so here we are. To simplify this, you have to multiply this negative 1 into both the 1 and the x squared, and this 2x into the positive 1 and the negative x. And don't forget this negative makes these terms, changes the value of these terms, so instead of positive 2x it's negative, and so forth. And so this is what we're left with here. And you notice there are some like terms in here. You have a negative x squared and a positive 2x squared. Those go together. dv1x squared, then you have negative 2x minus 1. Put all that together, and that's what we have. And that's as far as you can take this because you can't simplify these things. Nothing can cancel. So actually, that's going to be our answer right there. So the derivative of this function is going to be this polynomial here. That's the rate of change at any given point. All right, so let's take a look at another example. Look in your notes for this point here. This one says, find an equation for the tangent line to the curve at the given point. So we're finding the tangent line. So that is in the y equals. Okay, chances are it's going to be in the point slope form. And so it's going to look something like this. Okay, that's the form that it's going to be in. First thing, though, is we need to figure out what the slope is because they give us one of the point values. They give us the x. And to figure out what the y point value, just put -1 in there. So you'd have -1 to the 4th plus 2 all over -1 quantity squared. So you'd have 1 plus 2, that's 3 over 1. So then your y value is 3. So your coordinate is -1, 3. And then from there, we can go ahead and find the derivative. So why don't you go ahead and try this on your own. Go ahead and try it. You can pause it from here, try it on your own. You notice here, figure out what kind of rules you need to use and apply them, and then go from there. If you need a little extra help, then hang on, and then when you think you can go on your own, pause the video, go on your own, come back and try your work. Okay, so the first thing is, you notice it's the quotient rule. So it's going to be low d high minus high d low over low low. So low d high minus high d low all over low low. So that'd be x squared squared, so x to the 4th. Then you can simplify this. You would multiply this x squared in, so then that would give you 4x to the 5th minus 2x times x to the 4th. That's going to be 2x to the 5th. And then that negative goes into it again. That's going to be 4x all over x to the 4th. Okay, a couple things happening here. You notice these right here simplify just to 2x to the 5th. And then also everything has an x happening. So you can go ahead and factor an x out of every single term. So then it would be then just 2x to the 4th minus 4 all over, let's see, x to the 3rd. There it is. Okay. Now they want to know the tangent line at a specific point, so you need to find the slope at a point. So it's the slope at x equals -1. You always put x values, never y values in here, always x values, because the x tells you where. Okay, the y value is irrelevant when you're finding slopes at a point. So always the x value. So you plug the x value in there, so it'd be 2 times -1 to the 4th minus 4 all over -1 to the 3rd. And then when you simplify that, you should get +2. Yeah, because -2, yeah. So +2, and that's your slope. Now you have your slope and your point, so put it in point slope form, and that's your equation. So it'd be y is equal to 2 times x minus x, and that's -1, so x plus 1 plus your y, that'd be then +3, and then that would be your answer for the tangent line right there. So hopefully you're able to do some of these on your own and you're not needing as much help on them. This last one is going to be a little different story. Maybe I can set it up for you, then you can think about it and try to get it on your own, but we'll see. So application problem, talking about rates of change. The members of the Blue Boar Society always divide the pavilion rental fee for their picnics equally among the members. Currently there are 65 members and the pavilion rents for $250. The pavilion cost is increasing at $10 per year, while the Blue Board membership is increasing at 6 members per year. What is the current instantaneous rate of change in each member's share of the pavilion fee? And then answer in appropriate units. So first of all, we'll use M for members. Okay, so the amount of members currently is 65. And the cost, okay, is $250 currently. Now these two values are rates of change. So the $10 per year, that's the rate of change of the cost. So we'll go delta C, the rate of change of the cost, is $10. And then the rate of change of the members, delta M, is 6. All right. Then it says, what's the current rate of change in each member's share of the pavilion rental fee? So first of all, mathematically, how do we figure out the share? Well, the share is the total cost divided by the members, right? So if you want to know what each member is going to have to pay, you would take the total cost and divide by however members there are, split that up evenly among everyone. But they want to know the change in what people are sharing through time. So you notice you have one function divided by another, so you do low d high. So low d high. Remember, delta and d are the same, so I'm still using triangle, which is delta. So low d high minus high d low all over low low. Okay? Now, all you have to do is plug in your variables, where the members, so delta share, the change in the share fee, members is 65, the change in the cost is 10, the cost is 250, the change in the members is 6 members per year, and if any of these were negative, but everything's going up, okay, so you have to be careful. So if the members was going down 6 members per year, then yes, this would be negative, because sometimes some problems are going to be like that. Or if the pavilion cost was going down, then this would be negative, but they're both positive. All right, so let me just throw that little bit in there, but all these are positive. Over m squared, so that would be 65 squared. And when you put that in a calculator and simplify it, you'll get a value of negative 0.0, negative 0.20118. Now let's make sense of this. That represents, you can try this on your own again, try to make sense of this, pause it, and then this is the important part because you get points for this on the AP exam and on tests. Just trying to make sense. What does this mean in the context of this problem? Try it on your own. But in this problem, this represents the amount in cents. Okay, so it's going down 20 cents per year. So we'll say the share amount or the fee amount so we'll say the fee price, that's what each member pays. That's what I mean by fee price. What each member pays is going down 20 cents per year. All right, and so that's what that means. So that finishes up the second part of these notes. If we just really quick review what's in here, we have rates of change, and now we're looking at different properties of finding rates of change, which we now are going to call derivatives. And we're using all of these rules. One of them that we used was the quotient rule. When you divide two functions, low d high minus high d low over low low, that's the quotient rule. And then the other one is the product rule, the sip and piss rule, or the, this works for some people it doesn't help them remember it. But just remember it's the derivative of the first times the second plus the derivative of the second times the first. It's really simple. Okay, and it doesn't matter what order because you're adding and addition is commutative. However, for the quotient rule, it does matter because you're subtracting. Okay? All right, so go ahead and now that you have all of the notes, go ahead and complete the homework and ask me questions in class.